This presentation is an introduction to complex numbers and their operations. It is separated into two videos due to its length. Our approach will be to extend the basic mathematical operations that you're familiar with of the real numbers to those of complex numbers. Your objectives: define a complex number, graphically represent a complex number, add or subtract complex numbers, multiply complex numbers, divide complex numbers. Why are there complex numbers? Mathematicians were looking for a solution to the simple quadratic equation x squared plus 1 equals 0. If we look at this graphically, its vertex is at 0, 1, so there are no real solutions. Solving the quadratic, we have x equals plus or minus the square root of negative 1. You may recall from your early studies of mathematics that you were told you cannot take the square root of a negative number. Well, that's true when you're limited to the domain of real numbers. However, if we extend our domain to complex numbers, there is a solution to square roots of negative numbers. Mathematicians define the imaginary unit. They call it I, and it equals the square root of negative 1. If we square this, we have I squared equals a negative 1. This introduces some very interesting changes to our mathematical structure. To solve the quadratic from above, we have the square root of plus or minus the square root of negative 1 equals plus or minus I. To extend this to the square root of a negative number, our example is the square root of negative 17. We use our property of radicals to separate this into two radicals, the square root of negative 1 times the square root of 17. Square root of negative 1 equals I, so we have I radical 17. This allows for taking the square root of a negative number. As a shortcut, if you see a negative sign underneath the radical, rewrite it as I on the outside of the radical, leaving the real numbers underneath the radical. Simplify where appropriate. The definition of complex numbers is as follows. A complex number is defined as A plus BI, where A is the real part and BI is the imaginary part. A and B are real numbers, and I is defined as the imaginary unit. The set of complex numbers includes the set of real numbers, which you're familiar with, and we're now introducing another set of numbers, the imaginary numbers. As an example, V equals 2 plus 5i. V is an imaginary number with 2 the real part and 5i the imaginary part. It's part of the set of complex numbers. Here's another example. W equals 3i. It has no real component because a equals 0 in this case, and it's a pure imaginary number because w equals just 3i. When we write complex numbers, we write them in standard form. Standard form requires that we have a real part plus an imaginary part. Graphically, we graph complex numbers in what's called the complex plane, where the horizontal axis is the real part and the vertical axis is the imaginary part. Here's an example. 2 plus 2i. 2 is the real component. 2i is the imaginary component. We plot 2 on the real axis, 2i on the imaginary axis. Second example. Negative 1 minus 3i. We plot negative 1 on the real axis, negative 3i on the imaginary axis. It's really not much different than plotting points in the coordinate plane. It's just that the horizontal axis is the reals and the vertical axis is the imaginaries. Let's look at addition and subtraction. When we add our real components, then we add our imaginary components. As an example, we have 3 plus 4 is 7, minus 7i plus 2i is negative 5i. Reals to reals, imaginaries with imaginaries. You can treat the I as a variable. Subtraction is very similar. Subtract the reals and subtract the imaginaries. Here's an example. 3 minus 4 is negative 1. Negative 7 minus 2i is negative 9i. Multiplication and division will now be continued on the next presentation. Thank you.